Today we're going to be talking about other types of equations. The first type of equation that we're going to talk about are polynomial equations. A polynomial equation is the result of setting two polynomials equal to each other. General form, or sometimes called standard form, is when one side is equal to 0 and the polynomial on the other side is in descending order according to the variables. So, for example, x squared plus x minus 1, that would be in descending order according to the variables. The degree of a polynomial is whatever the highest degree of any term is, or the highest power. So now let's solve some polynomial equations. This is a polynomial equation, and the directions say to solve by factoring. So anytime we're solving by factoring, our first step in solving an equation by factoring is to get everything on one side equal to 0. And we want to get it in descending order, or general form. So to do that, I'm going to subtract the 12x squared from both sides of the equation. And I'm left with 4x to the 4th minus 12x squared equals 0. Now that I have it in descending order, I'm going to factor. Well, the first method of factoring that we always should try is to see if there's a greatest common factor. Is there a greatest common factor between these two terms? Yes, the greatest common factor would be 4x squared. So I'm going to factor out 4x squared, and I'm left with x squared minus 3. Well, once we have our equation completely factored, which this is, we can't factor any farther, then we take each factor, set them equal to 0, and solve. So my first factor, 4x squared, I'm going to set equal to 0. And I'm going to do the same thing with my other factor, x squared minus 3. I'm going to set that equal to 0. Having trouble with my zeros today. Okay, so for the 4x squared, to solve that, to get the x by itself, I would divide by 4 on both sides. And we know that 0 divided by anything is 0, so I'm left with x squared equals 0, and if I were to take the square root of both sides, the square root of 0 is 0. So I have one solution of 0. Let's see what other solutions we get. So for the other factor, to solve that, I'm going to add 3 to both sides, and I get x squared equals 3. And then I would take the square root plus or minus the square root, and I get x is equal to plus or minus the square root of 3. So I actually have 3 solutions: 0, the positive square root of 3, and negative square root of 3. Alright, let's try another polynomial equation. Again, we want to get everything on one side in descending order. So I'm going to subtract the 8x from both sides of the equation, and I'm also going to subtract 12 from both sides of the equation. You could do that in 2 separate steps if you wanted to, but I'm going to do it all in one step. So now to put this in descending order, I would have 2x to the 3rd plus 3x squared minus 8x minus 12 equals 0. Okay, so like I said, the first step when we're factoring is to look to see if there's a greatest common factor. Do all 4 terms have a common factor? No, they don't. So we have 4 terms, and the way that we factor 4 terms is by grouping. So I'm going to use the grouping method of factoring, and to do that we group the first 2 terms together and we group the last two terms together. But we need to make sure to look at this sign. If that sign in the middle is negative, that means we need to change the sign in the parentheses after it. Alright, so now that we've done that, we're going to look at each group and see what the greatest common factor is in each group. In the first group, the greatest common factor is x squared. So if I factor out an x squared, I'm left with 2x plus 3. Alright, in the second group, the greatest common factor would be 4. Alright, if I factor out a 4, I'm left with 2x plus 3. Now, I take what's common in both groups. If I look at both of these groups, as in this is a group and this is a group, the thing that they have in common is the 2x plus 3. So I'm going to factor that out. Factor out the 2x plus 3. And then I write what's left, which is x squared minus 4. Okay, so now I can take each factor and set it equal to 0. I could actually, if I look across here and I see that I can factor any farther, then I would want to continue factoring. Well, this can be factored again. I could do that, or I could go ahead and set it equal to 0 and use the square root method to finish solving this. But since it said to solve by factoring, let me go ahead and factor that. Alright, so I have 2x plus 3, and then that x squared minus 4 is a difference of perfect squares, so that would factor into x plus 2, x minus 2. Alright, so now it is completely factored. I can't factor any farther, so I will take each factor and set it equal to 0. 2x plus 3 equals 0. X plus 2 equals 0. And x minus 2 equals 0. Alright, so let me solve each one of these. Here I'm going to subtract 3 from both sides, and I get 2x equals negative 3. Divide both sides by 2, and that gives me x equals a negative 3 over 2, or I could change it to a mixed number, and that'd be a negative 1.5. And then subtract 2 here, and I get x equals negative 2. Add 2, and x equals 2. So I have 3 solutions, positive 2, negative 2, and negative 3 over 2. Okay, in this example, we already have everything on one side equal to 0, so we can go ahead with our next step, which is to factor. So let's first look to see if there's a greatest common factor. And there is a greatest common factor. The greatest common factor between 12 and 27 is 3, but they also have an x in common. So if I factor out a 3x, I'm left with 4x squared minus 9. And then we want to look to see if we can factor any farther. Well, that 4x squared minus 9 is a difference of perfect squares. So that would factor into 2x plus 3 and 2x minus 3. So again, if you were just solving this equation and you weren't told what method you needed to use, you could go ahead and finish that 4x. You could go ahead and, at this point, set each factor equal to 0, and then that 4x minus 9, you could solve it. Once you set it equal to 0, you could use the square root method to finish it. It really doesn't matter. Okay, so now that we have completely factored, again, we set each factor equal to 0. and solve. All right, divide by 3, and 0 divided by anything is 0. Subtract 3, and divide by 2, and I get x equals a negative 3 over 2. Add 3, and divide by 2, and I get x equals a positive 3 over 2. And those are my 3 solutions. Alright, we're going to try one more polynomial. Again, we have our polynomial already in general form. So let's go ahead and factor. Is there a greatest common factor between the 3 terms? No, there's not. Okay, so this is a trinomial, and we know that all trinomials factor into 2 binomials. And we go backwards from foiling. We know that whatever goes in the first 2 spots in our binomials have to multiply to give us this first term. Alright, so what can we multiply to get x to the 4th? It would be x squared. Alright, so x squared and x squared give us x to the 4th. Now, in the last 2 spots, they have to multiply to give us the last term. So what can we multiply to get 3? Well, the only factors of 3 are 3 and 1. Alright, so I know that has to be the case. And then we look at this sign. The second sign tells us if the signs in our binomials are the same or different. If it's plus, that tells us they're the same. And then this first sign tells us what they are. So they're both negative. All right. So now I'm going to go ahead and do the square root method for the rest of this. Like I said, we could continue factoring if you wanted to, but I'm just going to show you once we factor once, if you just set each one of those factors equal to 0, you can still solve it. Okay, so let me set these equal to 0. X squared minus 3 equals 0, and x squared minus 1 equals 0. Okay, so to solve this, I'm going to add 3 to both sides. And I have x squared equals 3. And then I'm going to use the square root method. I'm going to take the square root of both sides. And I get x equals plus or minus the square root of 3. That's two solutions, positive square root of 3 and negative square root of 3. And then for this one, I'm going to add 1 to both sides. So I get x squared equals 1. Take the square root, plus or minus the square root of 1. Well, the square root of 1 is 1, so I have plus or minus 1. So I have 4 solutions to this polynomial equation. Positive and negative square root of 3, and positive and negative 1. Alright, we're going to talk about a different type of equation now. A radical equation is an equation in which the variable occurs in a square root, cube root, or any higher root. So if our variable is under a radical, we're going to have to undo it by raising it to the opposite power. What I mean by that is, say if we have a square root, the opposite of square root is to square. The opposite of cube root is to cube. So we're going to be raising it to a power that's opposite of the root. Now, when we're raising both sides of an equation to an even power, we always need to check the proposed solution in the original equation, because we could have a solution that is called extraneous. And I'll tell you a little bit more about that in a minute. Alright, so when solving radical equations containing nth roots, if necessary, arrange the terms so that one radical is isolated on one side of the equation. And then raise both sides of the equation to the nth power to eliminate the nth root. So, like I just said, if it's a square root, we're going to raise it to the second power. If it's a cube root, we're going to raise it to the third power. And then we solve the resulting equations. If the equation still contains radicals, then we repeat steps 1 and 2. And then check all proposed solutions in the original equation. And the reason for that is, like I said, we could have extraneous solutions. An extraneous solution are extra solutions that you may get when you raise both sides of a radical equation to an even power. because of the fact that if I were to square -4, negative 2, I would get a positive 4. If I squared positive 2, I would still get a positive 4. So I can have two different possibilities to get to the same solution. Well, sometimes one of those possibilities isn't actually a real solution. So that's called an extraneous solution. So always check your answers when you're dealing with radical equations. Now, like I said, the title of this lesson is Other Types of Equations. So we did polynomial equations. Those are a little different, but from now on, the other types of equations that we'll be dealing with, the first step is always going to be to get whatever that different looking thing is by itself on one side of the equation. So in radical equations, the different looking thing is the radical. So we want to, for our first step, get the radical by itself on one side of the equation. So my radical right here, I want to get it by itself on one side of the equation. So to do that, I'm going to subtract the 3 from both sides of the equation. Alright, so I have the square root of x plus 3 equals x minus 3. Alright, so I isolated the radical. I got the different looking thing by itself on one side of the equation. Now, once we isolate whatever it is that's different, we want to undo it. So the way that we undo a radical is to raise it to the second power. So we're going to raise this side of the equation to the second power and this side of the equation to the second power. Now, when we raise a square root to the second power, it just cancels it out. So I'm left with x plus 3. But on the other side, I have the x minus 3 squared. Now remember, when we have a binomial squared, we don't just square each part. That means x minus 3 times itself. Okay, and then we need to FOIL that. Alright, so if I FOIL this, I get x squared minus 3x minus 3x plus 9. Alright, so that's x squared, if I combine my like terms, minus 6x plus 9. Alright, and now that I have gotten rid of the radical, this just turns into just a regular polynomial equation, so I'm going to solve it like I would any other polynomial equation. So to solve a polynomial equation, we want to get everything on one side in descending order. So I'm going to move this x plus 3 over to the other side. I'm going to subtract x from both sides of the equation, and I'm going to subtract 3 from both sides of the equation. Alright, so I have 0 equals x squared minus 7x plus 6. Okay, so now this is a trinomial. There's no greatest common factor, so trinomials factor into two binomials. Okay, the only factors of x squared are x and x. Now, 6 has two different sets of factors. 2 times 3 is 6, and 1 times 6 is 6. Now, which one of those would, again, we look at this to tell if our signs are the same or different. That's telling me my signs are the same. This is telling me they're going to both be minus. Okay, so I can go ahead and fill that in. They're both minus. Now, since they both have the same sign, that means we'll be adding our factors. So which one of these, 1 and 6 or 2 and 3, would add to give me 7? It would be 1 and 6. Okay, so now I've factored my polynomial. So I set each factor equal to 0. And solve. Alright, so I'm going to add 1. So x equals 1. and add 6. So x equals 6. Now, we're not done because, like I said, we need to check to see if we have extraneous solutions. So we need to plug these into the original equation to see if either one of those might be extraneous. Alright, so let's do that. I'm going to do it up at the top since I've run out of room. So I'm going to take the 1 and I'm going to plug it in to see if it works. So if I plug 1 into my original equation, every place I see an x, 1 plus 3 is 4. And the square root of 4 is 2. Alright, so I get 2 plus 3 equals 1. Does 2 plus 3 equal 1? No. So that means this is an extraneous solution. 1 was an extraneous solution, so it doesn't work. Okay, let's see about 6. Let's see if 6 works. So if I take 6 and plug it in where every x is, 6 plus 3 is 9. And the square root of 9 is 3. Okay, does 3 plus 3 equal 6? Yes. So 6 is my solution, my only solution. Alright, here is another radical equation. So the first thing we want to do is isolate the radical, but in this case it's already isolated. The different looking thing, the square root, is by itself on one side of the equation. So we can move on to the next step, which is to undo it, and we undo a square root by squaring both sides. So I'm going to square both sides of the equation. And when I do that, square and square root cancel each other out, so I'm left with x equals, and again, when we have a binomial squared, we don't just square each part, we write it twice and FOIL. Okay, so that leaves me with, if I FOIL this, I get x squared minus 6x minus 6x plus 36. Okay, so if I combine my two middle terms, or my like terms, I get a negative 12x plus 36. Okay, so I'm going to subtract x from both sides of the equation. And I have x squared minus 13x plus 36. Okay, so now everything is combined and on one side of the equation, the radicals are gone. So I need to solve this, and this is a polynomial. And so I'm going to solve this by factoring. And this is a trinomial, so this would factor into two binomials, x and x. Okay, so now 36 has a lot of different factors. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Well, which one of those factors would add to give me 13? It would be 4 and 9. And then remember, if this is a plus, then this sign tells me this sign's in my two parentheses. Okay, so they're both negative, and I'm going to fill them in with 4 and 9. Okay, so now that it's completely factored, I can set each factor equal to 0 and solve. Alright, so x equals 4 and x equals 9. Alright, so remember that doesn't mean we're done once we get the solutions. We need to check the solutions and see if we have an extraneous solution. Okay, so I'm going to check the 4 first. If I plug 4 into my original equation, every place I see an x, The square root of 4 is 2, but what is 4 minus 6? That would be negative 2. So that's not true. That doesn't work. So 4 is not a solution. Okay, so let's try 9. If I plug in 9, every place there is an x. The square root of 9 is 3, and 9 minus 6 is 3. So 9 is my solution.